Hey guys, welcome back. Today is the happiest day, or not happiest day, as it is the winter solstice. It is the shortest day to produce solar. So all I got today was a mere 7.43 kilowatt hours. Very sad. But that's not what today's video is about. Today we are looking at transfer switches. The Reliance ProTran2. Let's get started. So if you have a generator or a solar system or a solar generator, you'll need a way to get that power into the house to make it usable. Yes, I said it, solar generator. Cue the comment section. So today we are reviewing the Reliance Controls ProTran2 A510A Manual Transfer Switch. So I got this MTS from Nick online at altelectric.com, aka Jasper Generators. Anytime you can find a manual transfer switch for less than $500, you're doing good. Now there are many ways you can get power into the house from your backup power source. I'm going to explain two commonly used methods. The first and simplest method is a generator input box or generator inlet box. It looks something like this. It'll have a box with a generator inlet, and that'll be wired to your main service panel via a circuit breaker. And the circuit breaker will have a lockout plate that is very important so you do not backfeed the grid. So the main benefits from using an inlet box versus an MTS is ease of install, but the downfall is that you can potentially, if you don't have a lockout plate, you can potentially backfeed the grid. Another con of using the inlet box, in my opinion, is the fact that you will have to manage your loads. Using an inlet box is a per panel solution. So you're supplying power to your entire panel, except you're not going to have enough power to supply all your loads. You won't run your central AC, for example. So it'll be up to you to switch on and off the appropriate circuit breakers that you need to run and manage your loads that way. And since this is a per panel option, it's a backup option only. So you cannot run circuits simultaneously on the generator and on the grid at the same time. So it's either grid or backup power, and that's it. However, if you have a solar system and you want to use the power as much as possible 24/7, then you're going to want to use an MTS. So the most important feature of the MTS is that the loads are powered on a per circuit basis. Unlike the power inlet box, which is a per panel basis, when you do it per circuit basis, you can have some circuits running off grid and some circuits running off your backup power source at the same time. When I say same time, I don't mean two power sources feeding the same load. I mean your load can be switched between two power sources. In doing this, there is no chance of backfeeding the grid. Another feature that I like is if I need to do some maintenance on my solar system, I can just switch the circuits to line mode, and then I can shut down the solar system and just run off grid temporarily. So when you're looking for a MTS, there are two common brands out there. You got Generac, or you have the Reliance Controls ProTran2. Now for the ProTran2, there are a lot of different model numbers. Specifically with the suffix, it'll be A, B, C, D, and R. The A and B suffix indicates the box comes with a power inlet port. So this will be used to connect to your generator or your solar generator. You can also get these units that are hardwired. So if you have a sub panel, you can just hardwire it to your sub panel and supply power that way. The C indicates a watt meter but no power inlet. D indicates no watt meter and no power inlet. RA is the outdoor model, and that's for rain tight. The MTS comes in a 6 circuit or a 10 circuit configuration, and you can get them in a 30 amp or 50 amp capacity. Alright, so this is the Reliance Controls MTS. This is the A510A. It can handle a maximum watts of 12,500 or approximately 6,200 per leg. Single pole circuits, 10 amps at 125 volts AC. So if you had just used up all 10 120 volt circuits, it would be 100 amps, 50 amps per leg. Or 50 amps at 250 volts AC. And this is the indoor surface mount unit. So what's in the box? You're going to get a 16-inch piece of flex conduit, 1 inch. It comes with 2 bushings that go inside, just like this. You'll get some flex conduit connectors, an LB and a straight through connector, and the bottom half of the LB that is on the transfer switch itself. And these screws are for that bottom half. You'll also get screws for the front plate and for the power inlet connector. Here is the documentation that comes with the unit. Most importantly is this notice. The transfer switch, each circuit has 2 wires, a red and a black wire. The red will connect to the load center circuit breaker in your main panel, and the corresponding black wire connects to the appropriate load circuit. So this piece here talks about the power inlet. Make sure you're using a flanged inlet. Make sure the wire is suitable. So either 8 gauge through 4 gauge, so 4, 6, or 8. Do not use aluminum, use copper only. Use 3 number 6 screws and nuts. They don't provide any nuts, so I don't know where they came up with that. So do not solder or tin the conductors. The ground wire, green, connects to the G. The neutral, white, connects to the W. And the hot or black connects to either X or Y, the gold color screws. We'll talk about this later. 35 inch-pounds on the terminals. It's a 4 millimeter, 5/32 Allen wrench. Here is the user's manual. Goes over the basic installations. Shows you the different model numbers and their capacity and number of circuits, 4, 6, 8, or 10. And there is a couple warning labels. Specifically, this unit, since it's a transfer switch, has 2 power sources, right? It'll have 1 power source from a grid and 1 power source from your backup power source. So you have to make sure that both power sources are off before you work on the transfer switch. And other notable item is that this transfer switch works only with a non-bonded generator or power source. So your power source connected to your power inlet has to be unbonded, cannot be bonded. And the reason for that is if you were to connect a bonded generator or a bonded solar system to the power inlet port of the MTS, the neutral and ground wire going from the MTS to the main service panel, where there already is a bond, you'll end up making 2 bonded connections, and that can be potentially dangerous. I will talk about bonding more in the install video. So it is worth noting that the length of this conduit is 16 inches, so you will want to install your MTS no more than 16 inches away from your main service panel. So it has to be in very close proximity. The wire length coming out of the MTS for the wiring harness are actually 46 inches. Let's talk about these power inlet ports. There's 2 main ones that you'll find. You're going to find the NEMA SS2-50, or you will find the CS6375. Now they both look the same. The only difference is the 6375, the spec absolutely requires that there be this center alignment pin, whereas the SS2-50, there may or may not be this center alignment pin. So all this does is allow you to, when you're plugging in the cord, it just ensures that the cord goes in straight. It is not electrically connected, it's simply just a guide pin. And this has the ground here, which is this is the locking style port. So when you plug in your cord, you'll twist it to lock it. So if you're going to buy an RV cord for use with this port, you might want to get the one that does not have the pin coming out of the cord. That way you can use it with any of these plugs, whether it has the alignment hole or not. If you buy the cord with the pin, you're going to be forced to, it won't fit into the socket that does not have the alignment hole. So something to consider. Alright, here is the ProTran2. This is where your power inlet port will go. pop that off, put it right there. Let's take a look at the circuit breaker and the front features. You'll be met with this circuit description chart so you can map out your circuits. It's important to note that circuits A, C, E, G, and I, so that's A, C, E, G, I, are on line 1, the black wire, and it is monitored by meter 1 on the left here. B, D, F, H, and J, B, D, F, H, and J is line 2, the red wire, and that is monitored by meter 2 over here on the right. Alright, so as I said before, this MTS requires an unbonded power source for the power inlet port. That installs right here. So these meters have a maximum readout value of 7,500 watts, although you should never exceed approximately 6,200 watts on each line. These meters will display the power coming from your generator or other power source to your power inlet port. It is not going to monitor the power coming from the grid when you have it in line mode. So you can use these meters to help detect a power imbalance. So if you have a lot of 120 volt circuits, if I didn't have these 2 poles here, let's say you had all 120 volt circuits here, just the single poles, you're going to have to pay extra attention to make sure you don't overload one side or the other. Now if I had only double pole circuits, okay, since each pole contacts both sides, you're going to be using these equally, so it's not much of an issue. And you can get the box with or without these power meters. Alright, so let's talk about the switch operation. You can see here it has gen, that's when the switch is in the up position. There's an off position in the middle, so it's neither gen, neither line. And then you have line, which is the grid position. So when it's up, you're using your generator, and when it's down, you're using line. These over here are double pole switches. They correspond with a double pole breaker directly below it. If you need more single poles, like I am going to use, I don't have any double poles, you just take out this connecting rod right here. Jeez, it's a mile long. Alright, so now we have independent switches. So you would replace this with single poles, and then you could switch these independently and get more circuits. So if you remove all the handles, you're going to have a maximum of 10 single pole circuits. Likewise, on most circuit breakers that have this handle, you can remove this handle as well and convert this double pole circuit breaker into a single pole circuit breaker like these. Or you can just buy single pole circuit breakers and swap these out. Now the 510A is the base model. It comes with a 20 amp double pole in this position instead of the 30 amp. That's what I wanted originally, but it's nearly impossible to find that version, so I ended up buying the A510A, which comes with the 30 amp, which in hindsight is better because you get a 10 gauge wire on this position for the 30 amp breaker. But I'm going to swap these out for 20s. With that said, Reliance uses Siemens breakers as the default breakers that come with the unit. So if you want to buy additional breakers and you want to match the ones that are already in there, you're going to want to get Siemens breakers. But you can use any of the breakers that are listed right here on the panel. Siemens, Cutler Hammer, which is Eaton, or Murray, or Square D, Schneider, or GE. Basically any of these that are UL489 listed. Alright, let's take a look inside. You're going to remove these 2 screws on the front panel. This just pops off just like that. Alright, so you'll notice all the circuit breakers, and then there's wires coming out and going through the bottom outlet port there. So you're going to have this wire harness. This wire harness is 46 inches long. So make sure that that's basically what you have to work with. So keep that in mind. Alright, let's talk about the circuit breaker wires. For this particular model, this comes with a 30 amp breaker in the first position. Okay, so these wires right here are actually 10 gauge, which is nice because if you're running like a water heater or something that demands a little more power, you're going to have 10 gauge on these wires. The rest of these wires, okay, will be 12 gauge. These are all 12. So for these 15 amp breakers, you can upgrade these to 20 amps, no more than 20 amps from here all the way down. This position, you can have a 30. This is for this model. If you have other models, you got to pay attention to what circuit breakers it comes with and what the max can be. But generally speaking, you can have a max of 20 amps on any one of these circuits and you'll be fine, because it's going to be a minimum of 12 gauge wire. But the thing to note is you want to match the circuit breaker that's in your panel. So if you're going to swap a circuit that's 20 amps in your panel, then you're going to want to upgrade the circuit breaker to a 20 amp. If you're swapping a 15 amp circuit, you do not want to swap a 15 amp circuit on your panel for a 20 amp breaker. So you want to match these breakers with the circuit that you're replacing in your main panel. You just pop these out like this. You can see the bus there. You just pop these out, and you can just swap it for a 20 amp, whatever you need, single pole, double pole, and you're good to go. For me, I'm going to get rid of these. I'm going to get rid of all of these, and I'm going to have 20s all down the line, except for the very last one. I'm going to have 115 circuit. So for each breaker, you're going to have an input red wire and an output black wire, and they are labeled. So this is the G. So right here, circuit breaker. So this one right here. So the red wire will go to the breaker output on your main service panel, and then this will go back out to the load. You're also going to have a 10 gauge ground, and you're going to have an 8 gauge neutral. Let's talk about the power inlet and bus. So these wires can handle 12,500 watts. Okay, if you're using all 120 volt circuits, these ones, that would be approximately 6,200 watts per leg. So it'd be 50 amps on L1 and 50 amps on L2. So that would be a total of 100 amps. That's where they come up with that 100 amps at 125 volts and 50 amps at 250 volts. So if you had all circuit breakers that were all double poles, okay, it would be 50 amps for the whole bus, okay, at 250 volts. So that would be 12,500 watts. Let's talk about these power inlet wires. You got your L1 black and L2 hot, and you have your neutral. This is a number 8 gauge, okay, so that's sufficient technically. And you have these two wires are 10 gauge. This is where I take issue with this box, okay? This thing can handle supposedly 50 amps, okay? On a 10 gauge wire, are you kidding me? Per the spec, you can only have 30 amps max continuous on 10 gauge wire. Alright, so what do we do about these 10 gauge input wires for L1 and L2? Now Reliance, their stance is that these wires are short, 6 inches or so, so they will handle 50 amps for that short distance. But I don't like basing things on technicalities. So there's two sort of options that people tend to do with this. I've seen people actually upgrade these wires to like a number 8 minimum, technically a number 8, to match the neutral, which is a number 8 already. Or you can derate the circuit to a 30 amp circuit breaker. So for me, I don't need more than 30 amps per leg. That's still 3,600 watts per leg. So that's 7,200 watts we can put through this thing safely to power our loads. So I'm just going to go ahead and derate the circuit. But I'll probably upgrade the wires too. That's funny because I see this a lot, especially with these, like the Chinese batteries I do reviews on and stuff. They just scrimp on the wire. I mean, they're short wires. Like, what are you going to save? A couple bucks? Just oversize the wires. You can never go wrong oversizing wires, but you can certainly go wrong undersizing wires. All right, so a couple things to remember. This MTS is to be used only with unbonded power sources. When using the meters on the MTS, it is useful to balance your loads. So I have 2 inverters. Each inverter power one side of the MTS, so L1, L2. So I'll be able to see how much power is coming off that inverter, how much power is coming off that inverter, to make sure we're using the inverters equally. Okay, so the wire harness coming out of the MTS is short, 46 inches. That's all you have to work with. And the metal conduit is 16 to 18 inches. So make sure the MTS is located close proximity to your panel. So I'm putting mine on the inside of the garage and my panel's on the outside, so it's literally on the opposite side of the wall and just to the left. Okay, so for AFCI or GFCI breakers, if you want to swap out, or you need to swap out rather, like my bedrooms, they have AFCI circuit breakers, pretty common, for that extra protection for arc fault. You can do it on this MTS, however you have to add an additional neutral. So what you're going to do is, for this wire harness, you're going to add an additional neutral for each AFCI breaker or each circuit that you want to add. So I need to add 2, so I'm going to add 2 number 12 wires to this harness. I'll talk about this and I will show this in a future video. Alright, one more thing. This MTS, since it's an MTS, has 2 input sources, right? You have your generator input, or solar, whatever it is, and you have your grid input. So you have 2 power sources coming in, so it's especially prudent to take additional caution when working with this unit and to make sure both power sources are turned off before working with this unit after it's been installed. Alright, so one of the main takeaways from this video is how you intend to use your backup power source. If you have a generator and you want to use it in backup situations only, then you want to use a power inlet box. If you intend to use your power source all the time, or as much as possible, like a solar system, then you want to use an MTS. Speaking of solar systems, there are many other ways to get power into your house, but that's beyond the scope of this video. Alright, well, I hope you enjoyed this review of the ProTran, Reliance Controls ProTran2 10 circuit MTS. If anybody's using this unit and has dealt with these 10 gauge input wires, I'd like to know what you've done. So thanks for watching, and look out for the install video because that's coming next, and I'll see you on the next one. And if you don't want to wait for the next video, you can check out this one right here.